Here we have a problem on derivative. Okay, let's go over the question. Find dy over dx if y equals to x to the eighth power positive a to the power x positive a to the power a, where a is a constant. So that is we have to find the derivative of the given function with respect to x, because we have dx in denominator over here. So we have to find derivative with respect to x. Okay, let me write the given function as it is. That is y is equal to x to the power a positive a to the power x positive a to the power a. Okay, when I find derivative of this y with respect to x, I'll be getting dy over dx. Okay, here let's come to the first term on the right side. It's x to the power a. Actually, this is in the form of x to the power n. So whenever we find some stuff x to the power n and I want to find derivative of this one, I just have to use a power rule of derivative. So what is a power rule? So I just have to bring this exponent n in front of the variable and subtract 1 from the exponent. So this is the power of derivative. So the derivative of x to the nth power with respect to x is n times x to the power n minus 1. So actually this is in the form of x to the nth power, because here the base is a variable x and the exponent is a constant. So whenever the base is variable and the exponent is constant, and we have to use the power of derivative, which is explained over here. Okay, so now I can use the power over here. So then what I need to do is I have to bring the exponent a in front of the variable and subtract 1 from the exponent. Okay, now let's come to the second term on the right side. Here we have a to the x power. So can I use the power of derivative over here? No, we cannot, because the power of derivative that I explained over here can be used only if we have the variable at the base and constant at the exponent, so that we can use the power of derivative. But here the question says a is a constant. So we have the base is a constant and the exponent is a variable. So whenever the base is a constant, something like a, and the exponent is a constant, its derivative is, so to get the derivative of this one, we have to write this a to the x power as it is, and it has to be multiplied by natural logarithm, that is ln of the base constant a over here. So the derivative of a to the power x is a to the power x times ln a. So here you have a question. Instead of the constant a, what if I have some other constant, say 2 to the x power, because 2 is also constant. What is its derivative? We have to write this 2 to the x power as it is times the ln of the constant over here, ln2. So 3 to the x power. So 3 to the x power times ln of the constant over here. So e to the x power. E is also a mathematical constant. Its approximate value is 2.71828. What is its derivative? E to the x power ln and the constant over here. So but here we have natural logarithm. So for natural logarithm, the base is e. So in this logarithm, the argument and base are same. So the value of this logarithm is 1. 1 times e to the x power is e to the x power. Anyways, so just for a reference, I have explained all this stuff over here. Anyways, now we understood the derivative of the term a to the x power. So its derivative is a to the x power times ln of the constant and the base ln a positive. So here already we know that a is a constant. So here a constant is raised to the power of another constant a. So whenever a constant is raised to a power of another constant, it will be considered the complete stuff a to the eighth power is completely a constant. So the derivative of a constant is what? It's 0. So finally we get dy over dx equals to a times x to the power a negative 1 positive a to the power x times ln a. So this is the derivative of the given function with respect to x.